Whenever you go outside, it's a great time to think about all the things that hold the universe together. When you consider the scale of the universe, it's pretty easy to feel small in comparison. But guess what? You're probably even smaller than you actually thought. After all, me, you, this entire planet, everything in the night sky, that's all visible or baryonic matter, but it only makes up a fraction of the known universe. Out of all the matter in the universe, baryonic or visible matter only makes up roughly 15%. And when you take energy into consideration, that number drops to 5%. Although we don't have nearly enough time to talk about energy today, so for now, we'll be focusing on that other 85%, that dark matter as it's called. And that is where things start to get weird. How on Earth, or outside this Earth, did scientists figure out that 85% of our known universe is made up of something called dark matter? Well, the discovery of dark matter is usually credited to two main people, Fritz Zwicky and Vera Rubin. Zwicky observed clusters of galaxies and noticed that certain individual galaxies were moving way too quickly for the clusters to stay together. He hypothesized that there must be some extra mass there keeping it in place. However, his data was pretty inaccurate, and it wasn't until Vera Rubin came around that the existence of dark matter appeared to be verifiable. Vera Rubin was a Jewish American woman like me, but unlike me, she revolutionized our understanding of the universe by measuring the rotation of galaxies. Galaxies have planet-like rotation, meaning that the farther a mass is from the center, the slower it will travel. In more mathematical terms, the equation for planet-like rotation is v squared equals gm/r. But don't worry about what all those variables mean. Just notice how velocity, v, and radius, r, are inverses of one another. So as the distance, or r, increases, that means the speed, or v, should be slowing down. However, this isn't what Vera Rubin measured. Instead, Vera Rubin noticed that the speed of the galaxy stayed the same or even increased the further out she measured from the galaxy's center, implying that there must be some sort of extra mass. Clearly, there's a lot of evidence suggesting that there's something out there. But what is that something? What is dark matter? Well, we don't know. That's right, 85% of all matter in the universe, and we have no idea what it is. But we do have some theories. One of the first major candidates for dark matter are MACHOs, massive compact halo objects, which are masses such as black holes, neutron stars, or white or brown dwarfs. However, it is unlikely that there are enough of these masses to account for the amount of dark matter measured to be in the universe. Another option are WIMPs, weakly interacting massive particles, particles that, just as their name suggests, don't interact much with baryonic matter, but still have mass. There are experiments in process looking to detect such particles, such as CERN's Large Hadron Collider or the Super Cryogenic Dark Matter Search, but we still don't know if dark matter is really made up of WIMPs. Other possibilities include neutrinos or axions, but for now, we'll just have to settle for the fact that we don't know what dark matter is yet, and that's okay. Dark matter is pretty cool. The universe is a mystery, and there's so much left to learn, but science is a light that can help us illuminate the unknown. The only question is, what are we going to discover next?